All right. Hello, everyone. Nice to see you here today for our free prep hour. My name is Jerry. I'm going to be your instructor this evening. And what we're going to cover this hour is one topic on the GRE, combinatorics. And this is a topic I get a lot of requests about. I'll say right now, it's not the most important topic. And what do I mean by that? I mean, it's not something you're going to see a ton. You might see maybe 3, maybe 4, maybe fewer on the test. So it's less important than something like fractions, which you're going to encounter all the time. But these can be a little tricky at first, definitely intimidating at first. And I've found it hard to learn how to do them. So what I'm going to do tonight is try to give you some easy methods of thinking through them that when you're at the point when you're like, cool, I'm ready to start picking off some of those like miscellaneous final topics, combinatorics, probability, rates, things like that, that you're ready to look at this or take today's lesson forward with you and be ready for the end of the test. So combinatorics are all about how many different ways something can happen. And the first good news is these are pretty easy to identify. We're going to have something like this. Mikhail has 5 pairs of pants, 4 shirts, and 2 hats. If he wears exactly one of each kind of item, how many different items can he make? And the key that makes this a combinatorics problem is this last part. You're looking at how many different ways something can happen. So we're just warming up here. I'd like you to take a look at this question. I'll give you a minute to try it. Send me the answer when you have it, and let me know if you're stuck. Okay, so for this first question, one way we could do this, of course, would be to just list out all the combinations. However, this is pretty awful. It's going to get really long, really fast. And for anything even harder than this, it's going to be impossible. And even here, it's pretty much not possible within any kind of reasonable time. So instead, what we want to do is think about each decision being a number of forks in the road. So our first decision about the pants presents us 5 options. Each of those 5 options then forks into 4 more options. So we have 4 here, 4 here, 4 here, 4 here, 4 here. So now this 4 times 5, 20 different options of pants and shirts. And then each of those shirts forks into 2 hats. So this one forks into 4, the top one of which forks into 2, the top one of which is one of the 40 outfits that can be made. And so the simple way to do this is simply think about each choice, how many options you have for each choice, and multiply them together. This is what we'll call the slot method. The way this works is you start by drawing a slot for each decision. Then you label the slots. This is a step that maybe feels a little strange at first, but ends up being really important, as we'll see as these get tougher. Then you fill in each slot with a number of options for that decision. So in the last one, for instance, we have 5 choices for pants. And then you multiply them all together. I'd like you to try that with this question, and then we'll walk through this method a little more explicitly together. Send me the answer when you have it, please. Okay, so let's walk through this. Step 1, we draw a slot for each decision. We're choosing 3 people, so we draw 3 slots. Step 2, we label the slots. We have an assigner, a summarizer, and a host. And as I said, this will later become very important. Then we say, okay, how many choices do I have for the first slot? Well, we're choosing from 9 friends, so it's going to be 9. For the second slot, well, I have 1 less friend, so it's 8. 1 less for the third, 7. I take these and I multiply them, and I get 504. And in a case like this, that's going to be all we need. Again, in a little bit, we're going to look at how this can get a little more complicated. But for now, it's about following these steps. And really what it comes down to is asking yourself, how many choices are happening? In other words, how many slots? And how many options per choice? What number goes in the slots? If you can figure out the answers to those 2 questions, you've got it here. So let's try a couple of these out, and then we'll ratchet up the difficulty a bit. Great. And let me just remind you, if you're sending me answers, which I hope you are, make sure you send them only to me and not to everyone. So to start out with, we're choosing shells, meat, cheese, and salsa. So I draw 4 slots and I'm gonna label them. And the important thing to notice about the labels for now is these are all different from each other. Again, that's going to become important for us. Then we're just going to fill in the numbers. So we have 3 kinds of shells, 4 kinds of meat, 3 kinds of cheese, 5 kinds of salsa. I multiply all of these together and I get 180. So far, so good. So let's keep going. Again, these will get tougher as we go through the evening. If you're finding this easy, great. Sit with that. Make it automatic so that as it gets tougher, you're able to build on it. Okay, so this one's a little bit tougher. So let's start with the fact that we've got 5 questions. And these questions are all different from each other. So we can call it like question 1, question 2, question 3, question 4, question 5. And that's important to recognize because like if you're thinking about taking a test, like if I put A, B, C, that's different than if I put B, C, A, right? So each of these is different. And we can say that like the first 3 are going to be multiple choice. And then the last 2 are going to be true or false. So now we need to think about, okay, I've got my 5 slots, I've labeled them. How many choices do I have for each one? Well, I have 4 options for each of the multiple choice questions, and then 2 options for each of the true false questions. I multiply these all together, and I get 256. Make sure you're not, a couple of people sent me having added these together, remember, we're always multiplying here. So again, this comes down to those two questions. How many slots and what numbers go in the slots? Let's try one more, and then I'll pause to take some questions before we add another wrinkle to this. This one a little tougher still. I want you still to think about how many slots and what numbers go in those slots. Okay, so our first question here, how many slots? Well, I'm making a 10-digit number, so I've got 10 slots. What numbers go in the slots? And each of these, if I label them, it's like the first number, second number, third number, etc. And again, like there's an order here, so those labels are all different. Again, that's going to become important in a second. How many choices do I have for the first slot? Well, it's 2 and 5. So 2 different choices. It can either be a 2 or a 5. Second slot, either a 2 or a 5, a 2 or a 5, and so on and so on. When I multiply all these together, I have 10 2s, which is 2 to the 10th, 2 times itself 10 times. I have a question in the chat. What if this said only using the digits 2 or 5? Would that change anything? In this case, no. Now, what I think this person is picking up on is that in these problems, when we see and, we think multiplication. When we see or, we think addition. But it's still, even if it's 2 or 5, what the and or really is about is the first digit and the second digit and the third digit, etc. As opposed to if it's like, if it could be, we're choosing between 2 and 5, like a 10-digit number. All right, well, what would be something? A 10-digit number that's 2 and 5 or 3 and 6. And then that would be like, okay, here's the number of ways it could be 2 and 5 would be 2 to the 10th. And the number of ways it could be 3 and 6 would also be 2 to the 10th. And since it's this or this, I would add these two together. That's the case where or ends up mattering. We're going to see some of those later on. But for the most part, I don't want to confuse you too much with that right now. Just stick with the remembering that we're going to multiply these together. So I'd like to pause and take some questions because we're about to add another element to these. Any questions about what we've done so far? So the question is, could I do that with 5 instead of 2? The answer is no, because where this 2 comes from has nothing to do with this 2. I could change this if it said like 3 and 5. Let's change the problem. So using only the digits 3 and 5, it would still be 2 because it's 2 different choices. That first digit could be a 3 or it could be a 5. So there's 2 different choices there. If we were like only using the letters A and B, it would still be 2 choices, right? A or B. Does that make sense? So again, it's not about the values that are in there. It's about how many options do we have, right? It could be red and green, salsa and pico de gallo, whatever. Any other questions? Okay, so let's make things a little bit more complicated. So far, the only thing we've had to pay attention to is how many slots and what numbers go in the slots. But let's return to this problem here with Jane's book club, right? We saw the way we did this was we made slots for each decision, we labeled them, put in the number of choices for each, multiplied, and that was it. But in this case, each of these slots is different. And that's what we've seen with all of them so far, right? Here we've got these 3 different roles. Before it was like the first number, second number, third number, or like the shell, the meat, the cheese. But what happens if in Jane's new group, there's no assigned roles? Everybody's simply a member. If we just multiplied these out, we'd run into a problem. Because in the previous version, where we had these 3 different roles, you could imagine the same 3 people joining that group, but arranged in 6 different ways. If they're all just group members, though, these are all the same group. The group with Amit, Liz, and Mikkel is the same as the one with Amit, Mikkel, and Liz. So we have to somehow eliminate this double counting. The way we're going to do that is by adding a step 4. If any of our labels are the same, we're going to take this and divide it by the number of identical labels factorial. And just so you know what that looks like, factorial is notated by an exclamation point. So like 3 factorial, and that's equal to 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1, etc. You're just counting down, multiplying. So in this case, we have our 9 by 8 by 7. Because I have 3 m's, I divide it by 3 factorial. And then, importantly, make things easier for yourself. And rather than multiplying this all out and this all out, start out by doing some canceling. So I can reduce that 8 and that 2, I can reduce the 9 and the 3, and then I've got a much easier multiplication to happen here. And I end up with a lot fewer combinations than I had before. So we're going to use this usually when we're picking groups or picking teams. And when order doesn't matter. So it's a difference between, like, if I'm saying 3 people to go to the movies versus like who walks in first, who walks in second, who walks in third. If there's a difference between first, second, and third, then I don't divide. If there's no difference, then I do divide. So to recap so far, we make a slot for each decision. We label those slots. If the labels are all different, we just fill in with the numbers, multiply, and that's it. If the labels are the same at all, we have to fill in the numbers and multiply, but then divide by the number of repeated labels factorial. This may feel confusing at first, but we're going to practice it a bunch so it'll get easier. Let's try it out. Okay. So Vikram is bringing 4 friends. So we're going to make 4 slots here. And he's selecting, and each one is somebody going to the zoo. So let's call them a zoo goer. So they're all Z. And these are all the same. And I can think about that for a second and realize, like, right, bringing Alistair and Jeremy is the same as bringing Jeremy and Alistair. So these are all the same. So I know I'm going to end up using that step 4. And he's choosing from a group of 10 friends. So he's got 10 for the first slot, 9 for the second, 8 for the third, 7 for the fourth. I know I'm going to multiply these. But first, because I have these 4 things that are the same, I'm going to divide by 4 factorial. And before I do my multiplying, I'm going to start by doing some canceling. So I'm going to say 4 times 2 is 8. 3 goes into 9 3 times. This makes my life a little bit easier. I can just call it 30 times 7, which is going to be 210. Let me pause and take some questions about this. Send me your questions if you have them. If you're feeling good on it, say, give me like an okay or feels good or something like that, just so I know where you're at. Okay, so let's keep practicing. Okay, I have one person who's feeling confused. Let's try another one. And if you've got a specific question of where you're getting lost, try to let me know. But again, we're going to keep walking through these and hopefully it becomes a little clearer as we go. So again, I've got the steps down here. See if you can follow them. Okay, so we start out by writing out our slots. So we're having 5 team members. And then we know we're choosing from a group of 9 people. So we can say, how many different people can we choose for the first slot? 9. Once we've chosen one of those people, how many people are left for the second slot? 8. And this is how these almost always work. If we're choosing from the same pool, for each person we choose, that number is going to go down because there's fewer left. I've already chosen 2, so there's 7 left, etc. But then I'm going to notice that these are all the same. They're all just team members. So I need to divide by the number of repeated slots factorial. I've got 5 team members, so I divide by 5 factorial. And then I'm going to do some cancellation. and I end up with 126 combinations. Happy to take any questions here as well. Okay, let's keep going. We're going to make this a little harder now. So far, when we've done these and we've had repeated numbers or repeated roles, they've all been the same. We're now going to change things a little bit. So now we're looking for 2 guards and 3 forwards. See if you can figure out how this works and send me your answer, please. Okay. So once again, we set up our 5 slots and we label them. We've got our 2 guards and 3 forwards. And we fill in our numbers again, 9, 8, 7, 6, 5. And so far this looks the same. But of course, I notice I have repeated labels, so I'm going to divide. Question is, what do I divide by? Well, I have 2 guards, so I divide by 2 factorial. And I have 3 forwards, so I divide by 3 factorial. And I multiply those 2 together. So this is what's going to happen when you see multiple categories that get repeated. You take each one and divide by the number of repetitions factorial. Then, of course, I'm going to do my canceling again. 3 by 2 gives me 6. 2 by 8 gives me 4 there. So when I multiply these all out, I end up with 1260. Here's a piece of good news for you all. If you can do this problem, you can do most combinatorics on the test. Are there some that get harder, yeah. But like any topic, there are always going to be the super, super hard problems. If you can do this, you can do 80%, if not more, of the combinatorics that you're going to see. And given that it's not that common a topic, chances are this is going to get you what you need. So let's practice this a little more. Okay, so we start by drawing our slots. We're picking 3 shirts, 2 pants, and 1 pair of boots. And we're choosing from 7 shirts, so 7, 6, 5, 5 pants, 5, 4, and 2 boots. And then we're dividing by our 3 shirts, 2 pants, 1 boots, those all multiplied together. We can do some canceling, the 3 and 2 to cancel the 6, 2 to cancel the 2. We end up with 700 combinations. Hopefully by this point, this is feeling a little more manageable. And again, like I said, this is pretty much as hard as it gets. So let's sit with a couple more of these and hopefully it'll get stronger. I have a question. Why are we not dividing by 2 for the boots? Because there's only one B here. These numbers come from how many of those labels we have. I'm picking 3 shirts, so I divide by 3 factorial. 2 pants, so I divide by 2 factorial. I'm only picking 1 boot, 1 pair of boots, and I have 2 that I'm choosing from. But if I had 10 that I was choosing from, it would just affect this number, not this number. Does that make sense? Okay. So let's try another. Okay. So we're choosing 2 proteins, 2 veggies, 1 salsa, and 1 cheese. And now I'm going to fill in my options for these. 6 proteins, 4 veggies, 5 salsas, and 3 cheeses. I multiply all these together, but I also have to divide by my 2 factorial for the 2 proteins, 2 factorial for the 2 veggies, and then 1 factorial. You can pretty much ignore that, but we can put it there for clarity's sake for the salsa and the cheese. I can then cancel out this 4, and I get 30 times 15 times 3, so 30 times 45, which gives me 1350. Great. I'm seeing a lot of right answers in the chat, so it sounds like you all are really getting this. I'm really glad to hear that. Let's practice a little bit more, and then we'll add one more wrinkle in a second. Okay, so we're choosing 5 people total. We have 1 person who's the chair, and the other 4 are members. So again, that labeling step becomes really important here. Then I fill in the number of options I have for each of these. And it doesn't matter whether I put the chair here at the front or at the back, because ultimately multiplication is multiplication. These numbers are all the same. It doesn't make a difference. And then I divide by, I've got my 4 committee members, so by 4 factorial, I can do a little canceling. And when I multiply these out, I end up with 1260. Let's do one last one, which will add a final wrinkle, and then we'll wrap up. Okay, so here we have this added wrinkle, 1 or 2 proteins. And if we see this, that there's multiple ways we can choose, we have to take each possible way and add. This is where we have an or leads us to addition. So we need to look at the case where we have 1 protein and the case where we have 2 proteins. So for 1 protein, that's going to look like this. I've got my protein, my 2 veggies, my salsa, and my cheese. I put in my numbers here. 5 salsas, 3 cheeses, and I divide by 2 factorial for my 2 veggies. So I can cancel out my 4. I get 6 by 3 by 5 by 3, which gives me 270 options. Or I could have 2 proteins, in which case it gets set up like this. And we actually did this before. 2 proteins, 2 veggies, a salsa, and a cheese. And now I divide by 2 factorial times 2 factorial. So I can eliminate 4. I can eliminate this down to a 3. And then multiply again. 3 by 5 by 3 by 5 by 3 gives me 675. Oh, I think somebody's saying I got my number wrong here. I'm still getting 270 here. 4 options for veggies. Yeah, I'm still getting this. Anyway, because it's either 1 protein or 2 proteins, I'm going to take these 2 and add them together. And I end up getting 945 possibilities. Questions or thoughts about this? Okay. So this is a rare case that's going to happen. It's just you have to see if there's more than one way that something could be arranged. You need to think through those different arrangements and add them together. This is our OR scenario. But that's pretty rare, to be honest with you. For the most part, we make slots for each decision. We label the slots. If they're different, you just multiply and that's it. If there's any repeats, you divide by the number of repeats, factorial, and that's it. Hopefully, today's lesson was helpful for you. I wish you the best of luck in all of your GRE studying with this topic and others. I'm going to stop the recording now, and then I'm happy to stick around for a couple of minutes, answer any other questions you might have about the GRE generally, how to study, etc. But thanks for joining me for tonight's session.